Today I'm joined by Jamie Salter from the University of York St John's. Thank you for joining us, Jay. Really appreciate your time, and it's strange interviewing you considering we've known each other for a long time, and yeah, multiple conversations on this area as well. So, just for those who don't know you, it'd be great to give a little bit of background into what your role is, and yeah, where your interest into growth and maturation has come from.
Well, thanks for the invite, Steve. As you mentioned, I'm a lecturer and researcher at York St John University. I started my kind of career for this as a sports scientist or S&C coach working in football years ago. Like many athletes, wanted to be a footballer, wasn't good enough, so I ended up thinking, how can I spend the next 20, 30 years alongside footballers? So I started on that career path, sports scientist, S&C, worked for a few clubs, but my interest in what I do now kind of stemmed from my time at Middlesbrough, where we were seeing trends in injuries, players breaking down in terms of growth, overuse related injuries, which I admittedly wasn't overly clued up about at the time. But discussions with the medical staff and colleagues, we discussed growth and maturation in detail, and that's where I kind of took that on then for the department to kind of lead on that side to educate others around growth and maturation and try and enhance our practice. That kind of coincided with me wanting to work in academia and making that transition. So fueled by both of those, the applied and the academic kind of nature, I embarked on a PhD, and the PhD was in youth adolescent football, mainly around training load adaptation, how we can manage training loads for different players throughout an academy system to try and mitigate some of the injuries that we were seeing. So I was trying to actually come up with an applied outcome for the issues that I was seeing firsthand. So we didn't solve the problem, but I feel like the body of work that we've done so far has helped enhance knowledge, and we've got a bit further to go to kind of eradicate these issues properly.
Cheers, Jane. Like some of the research that you've been bringing out over the last couple of years, which obviously a lot of it was through the PhD as well, has been really enhancing the actual knowledge base around that as well. So you talked about training load and adaptation within the PhD. Do you want to just go into a little bit more detail on like what kind of like your main findings were around like the adolescent phases and what you were actually exploring as part of your PhD as well, please?
Yeah, so we looked at, my PhD had 5 studies. One was looking at practices, so whether people measured it, training load and maturation, and we found out that pretty unanimously people were collecting maturation and training load data, which meant that it was possible to do what we'd planned to do in everyday practice, because people were already routinely measuring at least some metrics of training load and some version of maturity offset or predicted adult height. Then we looked at the strategies. We, like other researchers, kind of arrived on the Camis-Roach predicted adult height being the preferred version in academy football for somatic methods. And then we looked at like some acute and chronic studies. So from an acute perspective, we looked at players' response to the SAFT. So I know you know that well, Steve, the soccer-specific aerobic fitness test, where we looked at movement patterns. Right? Yes. So rather than like a match play, which is random and obviously has so many variations in terms of their load, what we wanted to do was standardise what they did. So to actually look at differences in, one, the movement patterns, but also, two, the acute response to a set load. And what we found was that, not surprisingly, is that players going through the growth spurt had a more variable change. So some of them handled that quite well. Some of them struggled with that load, and their reactive strength index, their counter movement jump immediately following that was compromised. So they had a greater kind of or relative cost to that exercise. And not surprisingly, the post-peak height velocity players had a smaller drop-off, meaning they could handle the same load better. So that gave us implications to say, right, well, we know that one individual training session, we use that as a proxy for a training session, basically causes a greater hit to those players that are less developed. So therefore, you would assume, and again, we didn't measure fatigue in that extent, but we kind of inferred that they would, from a single training session, have greater fatigue, and therefore it would take them longer to recover, and they go into the next training session probably with some sort of residual fatigue, and therefore they're carrying a bit. And then what we did to back that up was a season-long study where we looked at all of the training and match loads that these kids did. We didn't measure objectively with this one with GPS, because that in 4 age groups in an academy system at that time was tricky. So we looked at RPEs. So they told us how hard they felt the sessions were. And overall, over the course of a season, what was really interesting was that a 5% change in predicted adult height. So if you were 5% more developed than other people in your age group, you had a 7 arbitrary unit reduction in load per session, which doesn't sound like a lot. So we use the CR100 scale. So basically, the more developed you are, the easier you found training. And obviously, the bigger diversity within your age group, so 5%, 10%, sometimes 15%, dramatically change that perception of load, which over the course of a week, 2 weeks, probably doesn't add up to too much in terms of that overall load. But over the course of a season, what we found is that between the least and the most mature children within each age group, there was around a 40% difference in annual training load, which is pretty huge considering they were on the pitch for the same amount of time and in the coach's eyes doing the same training sessions. So, and if you put that into context, if you're working with adult players, you're working with adults in a senior environment, that is controlled to the meter almost, as in like how much a player does in terms of their high speed running, their total distance, what exposures they get day to day. But yet in an elite child environment, we were letting these variations swing by around 40% within age groups, which for me was a red flag. And that indicated maybe why some of these children are really struggling with the load related injuries that are triggered, especially around the growth period.
I suppose it is one of the major challenges that's facing those working within youth sport, not just within football but across all sports really, is that variability and diversity of actually how do you go about managing these training loads within the adolescent players as well.
Yeah, it's really tricky because there are strategies that there's things like biobanding available, that there are ways in which we could do it, but they are logistically difficult to implement. So but take biobanding as a great example. What you need with biobanding is you need probably 3 or 4 age groups training at the same time in the same venue to allow that crossover of athletes to either drop down or drop up. If you don't have that, it becomes quite logistical in terms of parents knowing where and when they're dropping off their children to training sessions. And if that varies across the week, that as a parent myself, you need to know a routine, where you're going at what time and everything else. You need coaches to be on board, and if you're playing in biobanded groups but then playing in chronological age groups at the weekend, there becomes this kind of battle between, well, I can't prepare my team for the weekend because half of them are playing with that coach over there or that coach over there. So there becomes that kind of logistical battle. But there's also the empathetic angle whereby you might potentially be telling a child to play with another child 2 years below them in terms of their development, but that's based on physiology, not behavioural or cognitive development. So they might have the maturity of a 15-year-old and be quite comfortable in that environment, but when they're playing with under 13s potentially in a biobanding format, they might find that difficult from a psychosocial perspective because they're not on the same developmental stage. So there's all sorts of tricks that come with that, and I do think biobanding has a future, and I think it can be implemented well. But I do think other strategies like working with coaches to be smarter around how they manage loads within that age group session. So some players might be able to handle those sessions and they're fine, it leaves nothing on them, and they can do it again in 24, 48 hours, no problem. But at certain developmental stages, there are children that isn't the case. So they may need to be managed more individually within that session. And coaches, there's all sorts of strategies. I published a paper in Sports Health at the back end of last year that kind of gave coaches some strategies around area size, around overloading or underloading teams, where you can put players that are less capable of handling load on overloaded teams. So therefore, relatively, they're doing less running in each session. So you can manage that on the fly, but it does take a lot of coach education and understanding to know where their players are in terms of their development to be able to implement that effectively.
And it's interesting, obviously biobanding is a really hot topic at the minute, and I know you used it both within the research, and you're still doing some really innovative research in that space as well across the different levels of sport as well. So it'd be good to go into kind of as you say, while it's seen as a really good strategy, there's a lot of challenges around actually setting it up, and just hearing a little bit more about those in the recent kind of work that you've been doing as well.
Yeah. I mean, on the face of it, biobanding is it's a simple concept, as in rather than grouping players by their age or their chronological age, you band them by a metric based on their physical development. So in our case, what we tend to use is predicted adult height percentage, and there are thresholds for where an individual would be. So classically, 88% is kind of regarded as the kickoff or the start of peak height velocity. So anyone below 88% would be categorized as pre-peak height velocity. From 88% up to about 95, maybe 96%, you've got your circa peak height velocity. So those individuals that are going through that growth spurt, and then after that 96 are post-peak height velocity. That's typically what we use. Now, that's what on its own is a tricky concept, because that doesn't always mean that you've got even number of players in each group, in each band, because you're literally drawing a line. Whereas chronologically, coaches and recruitment staff will make sure you've got enough numbers in each age group in the right positions to be able to field the team and successfully set up and all that sort of thing. Whereas if you start chopping up squads based purely on where they are in a maturity, you're not guaranteed to have a goalkeeper. So we ran an event before Christmas here where we biobanded, and from a research perspective, we're working on the outputs now. We didn't have a goalkeeper in some groups, so the teams are going, well, who am I putting in goal? So we had to adjust it to modify it so that we could put a team out. So there's one logistical, are you going to have enough players in each position? The other one is the method that people use. So let's say, for example, York City, where I'm based at, arrange a biobanding event with Hull City, the closest one, and one club uses maturity offset, one club uses predicted adult height as their routine measure, and they're quite familiar with that. They turn up on the day, and it doesn't work because we've shown in a paper that the interchangeability between those methods is poor, about 50% at best. So one club could have categorised a player in one band, and the other club, who's got a similar player but they've got, they're using a different approach, has categorised them differently, and therefore they're playing in a different band. So having that consistent approach across academies or across organisations is super important to make sure that players are actually categorised in the right way. And then, like I said before, you've got that kind of psychosocial approach, as in we're doing this on a physical level. Sometimes parents and players themselves don't like being told that their child's not ready to play at the level that they're used to playing at. And although there's reasons for that, and actually in the long term it will probably do the athlete better in their development, communicating that to a parent that it is quite difficult, and obviously that's comes with a tactical approach about how you do that and why you do that. So yeah, there's all sorts of limitations with it.
That's good. One of the really interesting things I found about the whole growth and maturation, you talked a lot about physical side of it, and I've got 3 or 4 questions around this. So I'll ask you the first one. Like, why is it all based around the physical element? Is there been any research into, okay, well, we know that some late developers actually, if they're leaders on the pitch, are likely to still show certain characteristics that are more mature than those who are early developers but not mentally. So is that one of the challenges, that we're only setting this off a physical element rather than accounting for the others?
Yeah, definitely. I mean, from a cognitive and behavioural development perspective, this is a loose kind of reductionist approach, but generally it's a more linear development. So if you were to go into schools, obviously there are outliers in everything, but typically children develop in maturity, cognitive and behaviourally, at a linear rate. So there's less variation within age groups. So they have the same interests, they have the same kind of maturity in terms of how they manage themselves and take autonomy for themselves, all that sort of thing. It kind of goes in a fairly logical way. That isn't the case with physical, which is, I think, why it has such a big interest and why we derive our biobanding on this. But it's also, there is a bias within the research around early maturing players being given advantages. So that's probably where it's driven, is if you look at the research from numerous sports. I mean, a lot of my work is in football, but this has been published in lots of sports. There's an early developer selection bias. Whether you look at relative age, which is separate to maturity, but children born earlier in the school year or the competition year, depending where you look, tend to do better purely by proxy of just having more time to practice because they've been around more. but then they look better and they're recruited, and then they're in the system where they get exposed to high quality coaching and everything else. Maturation's the same. So you've got an individual who's one year, 18 months ahead of the curve from a physical perspective. They're going to look better in terms of their strength and power sports, definitely. In a male setting, females, there is less research on this, as in we think it's the case, but because of the changes that happen at puberty with girls, we're not so sure. I don't think it's as clear as in when they hit puberty and start having those hormonal changes. The performance enhancements aren't the same in girls as they are in boys. It's really clear in boys that they just take off from a strength and power perspective. There is a little kick in girls from some kind of data that we've got that's not yet published, but it's definitely not as dramatic. So there's more work to be done in girls to explore that. But I think from a physical perspective, those changes are clear, where they're less clear in other perspectives. And obviously the technical elements, it definitely changes what they do on the technical side, because if you're physically able to dominate, you might consider that your strength and therefore use that to be able to run with the ball or sprint and knock the ball past people, rather than actually using technical decision making rather than anything else.
Yeah, because that's a good follow up to the next question. Is it around we tend to focus on the physical outputs, but has there been any consequences of biobanding or just staying in your chronological age groups that you've seen where it's impacted the technical, tactical, psychological elements of the training load or just the exposure that players are getting?
Yeah, I think in terms of consequences, it's really tricky to kind of make informed decisions about this, because growth and maturation is relatively new field, as in the last 5 or 10 years there's a lot of research on it, but before that there was research, but they were nowhere near the volume there is now. So there aren't actually many studies that have tracked the outcomes for these players. So although we can say that early developers are advantaged and late developers are disadvantaged, there's actually very little evidence to support that as yet in terms of the longitudinal nature. So we have to be careful around that. But there definitely is a tactical and technical kind of implication for children, in the fact that the less mature individuals have to rely on that, and they may develop the underdog hypothesis, I guess. They have to rely on the ability to be resilient, to face adversity and to get through that. And if they can stay in the system long enough, those players typically are the better players, because they have the technical proficiency, because that's how they've had to survive. They have had the adversity of maybe being lower in their age groups, so therefore they've had to develop resilience, they've had to overcome all of that side of things, so they potentially become the more rounded player when they're older. But the system at the minute is that we recruit early developing players in football again, but in other sports, and therefore we don't actually see those players make it far enough, the less mature players, because they're removed from the system too early. But those that do stick in there tend to be better. We have worked on some data at the minute from the biobanding event, using the player maker devices, where we looked at the physical and the technical responses in those games. So in the morning we did chronological, in the afternoon we did biobanded games. From a physical perspective, there was no difference, as in there was very little difference in the overall kind of whole group findings between chronological and biobanded, which I think when you look at it on surface level like that, people go, well, what's the point in biobanding then? Why would we do it? But actually, if you knuckle down, which we did, to look at the within group differences, it did change the profiles of early versus late developers. So late developers were able to do more. They worked at a slightly higher intensity, whereas more developed players actually had to raise their game because they were playing against other well-developed players. So they had to step up from a physical perspective. So it challenged those guys more. But the biggest findings were in the technical aspects. So what we saw was that, as you would expect, in the chronological age groups, the more developed players were dominating. They had more time on the ball. They ran with the ball more, so their average possession time was longer. But when we flipped that into biobanding, it reduced those differences between the early and late developers, therefore meaning that players just, it evened the playing field, leveled the playing field. So when you think about the technical and physical development, that biobanding has been and will be a good strategy to do this if you can overcome those barriers that we said before.
Before I go on to two geeky questions, I suppose you mentioned around like strategies again to support these as well. What do you think are the future strategies to support athletes and coaches around these kind of like areas of interest? We'll call it within the growth cycle as well, other than
Yeah,
biobanking, of course.
yeah. I think although I think there are some other strategies out there, there's all sorts of things like maturity ordered shirt numbering. You have to be careful how you say that. It's a wordy one, but you from a recruitment perspective, there are things out there that you can do to get your recruitment right. But I don't think this going away. I think the nature of sport in general, but particularly football, is becoming more athletic. The demands are higher from a physical perspective, and clubs are always going to want athletically capable players, and therefore in the recruitment systems, that's going to be your early developers. So I don't think it's going away, but I feel that decision making should be maturity conscious, I call it. So it shouldn't make the decision. That's definitely not what we're saying, because there's numerous factors that come into decision making with academy players, but it should be a conscious decision based on their maturity. So that means that recruitment staff need to be aware of this. It needs the coaches to be aware of where that individual is and what they've got left to come. And I think that obviously the sports science and medical staff, who are probably the strongest at this, could relay that information better in terms of communicating to coaches, players, parents, what it means, what's the implications of this over the next 6 to 12 months for that individual, so that everybody could be informed and on the same page. Another strategy is looking at talent estimation or talent potential. So there's some really cool research. Stephen Cobley's group down in Australia and Adrian Sadao in France. Some really good research groups that are looking to almost predict performance whilst considering growth and maturation and relative age, if you like. So you can start to get some really nice projections of where these individuals might be. That has two things. One, the club can get a bit of confidence about their estimation and decision making, but also for the players themselves, if they're not predicted to be where they should be in terms of where the club wants them, they can make decisions earlier about, is this sport really for me, and actually try something else. Because there is nothing worse, and I've seen this, and you'll have seen it as well, is 15, 16 being told that your dream to become a footballer is not going to happen. And actually, they probably knew that a year, 2 years before, but they were just hoping and trying that something happened. So maybe we can make better decisions, maybe transferring to other sports, maybe giving that individual time to focus on their GCSEs or whatever else they've got without the stress of trying to stay in the football system would be a wise decision for the development or the overall outcome of that individual.
And it's really fascinating. Again, you talked about talent identification within there as well, and it's a really interesting topic, and especially see so with the project that we're doing next week as well. That's obviously good timing as well. Like you talked about, and so we'll combine like the next question into one. Like so, talent identification and trying to get growth and maturation measurements. You've talked about that as being one of your challenges. If you're trying to do a wide scale project over a couple of thousand kids, what's like a criterion measure of growth and maturation, but then to scale it across that many, you talked about different methods. It'd be interesting to see how you would overcome that challenge as a solution as well.
Yeah. So there's obviously a range of methods that you can use, and it depends on your resources. Like you mentioned, the number of children you're going to be doing, and obviously the reason you're doing it. So typically the gold standard is X-rays, but you would only do that if you had a real medical reason to do it. If there was an underlying issue or a concern of an issue from a medical perspective, it's kind of reserved for that. Yes, it's what we would class as the gold standard, but obviously exposure to radiation, cost, resources, it's difficult and tricky to do. There is now sonic bone, or there are other versions as well, where you get an ultrasound of the left hand and wrist and uses a very similar method. The bonus of that is it's portable and it's digitized, so the X-ray you need a radiographer to interpret that, and obviously the accuracy of that depends on their experience of that method, the Fells or Tanner, whatever you use. So you end up with some variability in those results, whereas the digitization of that removes all that subjective human error, and it does that. So that's a benefit, although that's costly. So you wouldn't be able to do that, and it does take a bit longer than a standard height and weight. With 2,000 kids, you'd have to pick a few of those and do that with those. So that's the method that's probably out there. The simplest way that we do it, which is we try and get parent heights for everything that we do. So whenever we test clubs or teams or we do work on projects, we try and get parent heights at the point of consent. So you send out your parental consent working with children, we try and get parent heights at that point. If we get that, that means that we can use the Camis-Roche predicted adult height method. So if we've got enough of those parent heights, we'll go with that method. And to do that, the only other thing you need is standing stature and body mass. So it's really quite simple to get large numbers through if you've got those parent heights at the point of consent. That then means that you can do follow-up measurements as and when you need to with those groups, typically every 3 or 4 months, and you can get a really nice trajectory of where those kids are going with that method. If you don't get parent heights, and I know this is tricky in some cases, and a lot of clubs choose not to do this for kind of ethical reasons, then you can use one of the maturity offset approaches. And the only variation you need from before that is the sitting height. So we typically measure standing stature, sitting height, and body mass as a routine, because it allows us to drop in and out between the methods. And I know I said before that interchangeable between the methods is not good, but I think depending on the project, we aspire to use the Camis-Roche, but if we can't use that, then we have to go to the other method, and we'll use that solely on that project. So that's where the interchangeability drops off, and that's really tricky. That's really easy to do. Measuring standing height, sitting height, and body mass can take 60 seconds per athlete if you set it up right, and you type it straight into a spreadsheet, and then you're off. We have now developed an app, Maturity Monitor, which is available to allow people to do this wherever they are. One of the problems with this was if you're in the know, if you like, if you're experienced and you work in a club, an organisation that, like on the PMA in football academies, for example, you can input that. But outside of those worlds, it was quite tricky to go through the murkiness of, what method do I use? What do I actually collect? What does it mean? Or how do I actually go through that? So we've developed Maturity Monitor, which is a freely available app for parents, teachers and coaches. There's videos on there how to measure height, weight and sitting height. You put the numbers in and it punches out the maturity for you, and you can again track that over time. So hopefully that's one way of making it more accessible for everyday people at grassroots to be able to be aware of this, because I think awareness is the biggest thing. If people are aware, it starts to become part of the typical conversation and decision making.
Right, that's brilliant, Jay. Thank you. I suppose last comment or last 2 questions, because I knew this would happen to us. We ran away with the conversation. We've lost track of time, but that's never a bad thing as well.
Yeah, good.
What's been your favourite research project to work on? And then what is the future one that you would like to do? I'll try and keep that within 2 minutes or so.
Yeah. There's so many that I could say, and I think because they're all linked as well, you're kind of moving forward in the next step. I've really enjoyed. We've done some girls stuff. There's 2 projects really. The biobanding one that we've done, obviously you've been involved in, I think is good. It's the largest biobanding study that's been done. It's in 11-a-side football, which again hasn't been done, and I think I'm really excited looking at the outcomes of that, because we've tried to look at that from a holistic perspective, so the physical, the technical, the psychosocial impact of biobanding. So that's a cool one. But the girls, we're doing some work with the girls because of this void in the research around girls and growth and maturation. So we've done some reliability stuff with some measures. Then we've looked at kind of anaerobic speed reserve and how that affect and changes through girls. But we're also really excited to start some injury stuff with girls to look at how growth maturation might affect girls in injury. And there have been a few studies, but they're literally a handful in comparison to boys. So I feel like that's something that I've been really enjoying getting to know and figure out maybe some of the differences between girls and boys. In answer to the second question, what's next? That's one that I'm really excited about in terms of what is next. But also I'm really keen to start looking at correction of performance scores based on this. There are, like I mentioned before, there's some really good work going on, but particularly in athletics type sports. because they are so driven by the time it takes you to cross the line and whatever, or the distance you jump or the distance you throw, that is all hugely affected by biological maturation. And I think when individuals in athletic sports, for example, are selected for regional or talented training environments, it's based on the numbers they're putting out in their performances. But again, that is hugely affected by the stage they're at in maturity. And a lot of those sports have 2-year age bands. So you might be in an under 15 competition, but actually just over 13, and you might be a late developer. So you might be potentially 3, 4, 5 years behind someone in your category. So of course you're not going to be throwing as far or swimming as fast or running as quickly. So to look at how we can to maybe look at that and maybe some of the mechanisms why, potentially using some of the equipment that you guys have in terms of looking at the underlying mechanisms as to what it is that changes during that would be really exciting.
I think that's a good lead on for us to go work on it next week as well, anyway, isn't it?
Sounds like a good plan.
Yeah, just wanted to say a massive thank you for joining us, Jay, and for anyone that wants to get in touch with you or liked what you were listening to, what's the best way for them to get in touch with you after the podcast?
So I'm always on LinkedIn's probably the best one. I think Twitter's changed into a bit of a strange place recently. I am on Twitter. X, sorry, as it is now, yeah. I am on there. But I tend not to do too much on there. LinkedIn is probably the easiest place to see what we're doing and to get in touch. And obviously email as well. Obviously, if you put the email on the bottom of the notes, Steve, more than happy for people to contact me about that. But yeah, I mean, I'm just really passionate about moving this whole area forward. So people who've got questions or want to share ideas or challenge ideas, then by all means get in touch.
Thanks, Jay, and thanks everyone for tuning in, and we'll speak to you soon.